Hi class. Now let's talk about triangles. So in your subject, solid mensuration, I have given from the previous module the general concepts about polygons and other plane figures. Now let's talk about triangles. This is just a review of your trigonometry because some of the formulas here you have encountered in your subject trigonometry. So first, let's classify uh, triangles. Okay, so triangles may be classified according to its sides or angles. So first, let's classify it according to sides. Okay. By the way, triangle class from your previous module is polygon with three sides. Okay, so triangles are classified into three according to its sides. So we have an equilateral triangle, isosceles triangle, and scalene triangle. So an equilateral triangle is a triangle with three congruent sides and three congruent angles. Each angle measures 60 degrees. So equilateral triangle is also an equiangular triangle because its three internal angles are all equal. Okay, so but basically equilateral triangle is a triangle with three equal sides. So next, isosceles triangle is a triangle with two congruent sides and two congruent angles. Okay, so here, as you can see, these two sides here are congruent. So, and its opposite side are also congruent or equal. Next, scalene. Scalene triangles are triangles with no congruent sides and no congruent angle. So the length of the three sides are different, and also the angles are also different. Okay, so now let's move on to the triangles, the classification of triangles according to angles. So triangles may be classified according to angles as right, oblique, and right or oblique. And from the oblique triangle, it can be it has three types: the acute, equiangular, and obtuse. Okay, so let's talk about the first one. So a right triangle is a triangle with a right angle which measures 90 degrees. Okay, and an oblique triangle is a triangle with no right angle. Okay, and under the oblique triangle, we have three types of oblique triangle. We have acute, that is a triangle with three acute angles. Acute angles means an angle that is less than 90 degrees. Equiangular, a triangle with three congruent angles. Each angle measures 60 degrees, as previously mentioned. Obtuse now is a triangle with one obtuse angle. That is an angle that measures more than 90 degrees, but less than 180 degrees, and two acute angles. Okay, so now let's discuss about congruent and similar triangles. So we can say that two triangles are congruent when they have the same shape and size. So congruent triangles can be made to coincide part by part, and the corresponding parts of congruent triangles are congruent. The symbol of congruence is shown here. Okay, similar triangles. What is what are similar triangles? Two triangles are similar if their corresponding angles are congruent and their corresponding sides are proportional. Similar triangles have the same shape but differ in size. Okay, as shown here from this example. So basically, congruent triangles have congruent angles and congruent sides. And on the other hand, similar triangles have congruent angles, but its corresponding sides are proportional. Okay. Now, from the properties of a similar triangle, since its sides are proportional, we have these following relations that are useful in solving problems regarding similar triangles. Okay, so letter A, this shows that the ratio of the corresponding of two sides of triangle is equal to the ratio of the corresponding side of another triangle, which provided that the two triangles are similar. Okay, and next, the ratio of the area of the two similar triangles is equal to the square of the ratio of the two corresponding sides of the two triangles. And lastly, letter C, the ratio of the perimeter of the two similar triangles is equal to the ratio of the two sides of the triangle. So now I think this is you already know this because these are all part of your subject trigonometry. So let's just take a quick recap. Okay. So what are the parts of a triangle? So we have base, the vertex angle, and the base angles. So I think since this is your module, you can just read this class, okay? Because uh, I have given this to you, so just read your module first. Okay? And these are the parts of the. Let's first look at the properties of triangle centers. So we have four triangle centers. So we have the orthocenter, the centroid, the incenter, and the circumcenter. Okay, so you can just read this class. So the definition of each triangle centers. Okay, so it is important to note about the Euler line. So the Euler line is the line which contains the orthocenter, the centroid, and circumcenter of the triangle. Okay, so the centroid is between the orthocenter and the circumcenter of the triangle. Okay, so the orthocenter is the point of intersection of all the altitudes. The centroid is the point of intersection of the three bisector of the triangle. So we can actually read here the definition of each triangle center. And the incenter is the center of the circle inscribed in the triangle. Okay, so now let's talk about the altitude, median, and angle bisector formulas. So again, you just have to read this class. It's very straightforward. You can follow this, and then you can read about the facts about the triangle, which are all useful when solving problems. So just read this class so that here, just read this one, okay? Then, so then we proceed to the area of the triangle. So these are the useful formulas in solving for the area, depending on the given. Okay, so if we have a given the base and the altitude, we can use this one. Area equals 1/2 base times height. If the givens are two sides and an included angle, then we can use this, the so-called scissor formula. So, or side angle side formula. So 1/2 AB sine theta. And if all three sides are given, we can use this formula, the Heron's formula, or three sides formula. Okay. So it is also important to note, class, that for you to solve all the parts of the triangle, you need to have at least three given, either, and one of those three must be a side. Okay. So if you want to solve all the parts, we have three sides and three angles. So you must have three givens, and one of it must be a side. Okay. So you cannot solve a triangle if you have three given angles. You need at least a given side. And special case is the right triangle, because you already have a given angle, which is the right triangle itself, the 90 degrees. So you need only to have two additional given in order to solve all the missing parts. Okay. So these are the sample problem. You can um, read this class and analyze. It's very straightforward. We have several problems that will help you understand how to use the formulas that I have discussed. But now let's solve some problems regarding triangles. So using the formulas that I have mentioned in our module. Okay. So first, let's have this one. So a triangle has an area of 845 square meters and a perimeter of 136 meters. If one of its side measures 48 meters, find the length of the shortest side. Okay. So first, let us write the given. Palitin ko na lang, class. Tapos i-zoom in natin. Yan. Okay. So what are the given? Sorry. So we have the area equal to 845 square meters and the perimeter, which is equal to 136 meters. Okay. And one side, let's say A, equals 48 meters. So what is the required? So our required is the shortest side. Okay. So let's say B. Okay. So we have a triangle here. So if this is A, sorry, this is triangle ABC. So this must be A, B, and C. A is already given, which is equal to 48 meters. Now we need to find the shortest side. It's either B or C. Okay. So we nagloloko yung notepad ko. Okay, now let's solve this problem, class. So what would be our solution here? So our solution. Okay, first we have two unknowns here, B and C. So to solve for these two unknowns, we need two equations. So where can we find those two equations? From the given. So we have an area and perimeter. So we will use that given to solve to establish our two equations. So first, let's use our perimeter. So our perimeter is equal to the length of the three sides, which is A plus B plus C. So if this is 136 and our A is 48 plus B plus C, then B plus C equals 88. So this is our equation 1. Or let's say C is equal to 88 minus B. So this is our equation 1. Okay. Now we have our equation 2. Given that we have an area, the perimeter, and 3 sides, what is the formula that comes out of your mind based from the given? We can use the Heron's formula because we already have the perimeter. So we can solve for the semi-perimeter. Also, we have the sides to be used. Okay. So if our semi-perimeter is equal to P over 2, so we have 136 over 2. So this is equal to 68 meters. This is our semi-perimeter. So using Heron's formula, our area now is equal to square root of S times S minus A times S minus B times S minus C. Now let's square this. So our A squared equals S times S minus A, S minus B times S minus C. Okay. Now, what else? Okay na? So let's substitute the given. So we have 845 squared is equal to 68 times 68 minus 48 times 68 minus B times 68 minus C. Okay, so this is our equation 2. Now let's substitute equation 1 to equation 2 to eliminate the variable C. Okay, so we have 845 squared is equal to 68 times 20. 68 minus B, times 68 minus 88 minus B. Okay, but if we distribute this one, so we have this becomes minus 88 plus B. Okay, now let's simplify. So let's divide this both sides by 68 times 20. So we have 145 squared over 68 times 20 equals this one. This can become, this will become 20. Yes, yes, 20. So let's write this down. 68 minus B times 20. Negative 20, I mean. So this will be B minus 20. Okay. Now let's distribute. So this becomes 845 squared over 68 times 20 equals 68B minus B, minus 68 times 20. So ilan ba yan? 68 times 20. We have 68 times 20. 1360. So we have 1360 minus B squared plus 20B. Okay. So let's transpose all these terms to the left side. So we have B squared. So 68 plus 20 is 28. So and it will become negative 88B plus 1360 plus 845 squared over 68 times 20 equals 0. So we can solve for B. So let's do it. let's just go to mode 5 2 using a mode 5 3 quadratic equation. We have 1 negative 88 1360 plus 845 squared divided by 68 divided by 20. 51.14, 51.14, and the second root is 36.86. 36.86. So definitely our shortest side must be equal to 36.86. So if B equals 36.86 meters, from equation 1, our C is equal to 88 minus 36.86, which is equal to 51.14 meters. So actually, these two roots are the length of the other two sides that we have, what that we are solving. So therefore, the shortest side is equal to 36.86 meters. Okay, so this is the answer. Okay, now let's proceed to another example. So this one. Okay. So the sides of a triangle are 127 meters, 188 meters, and 203 meters. It is divided into two equal parts by a line parallel to the 188 meters side. So find the length of the dividing line. Okay. So let's solve this class. Say we have this triangle. Sorry. Okay. Pangit. Yan, ganyan. Morning po. Yan, okay yan. So say this is our 188 meters side. This is our 127 meters and 203 meters side. So a dividing line is drawn parallel to the 188 meter side. So suppose this is the dividing line here, and let's call it X. So this dividing line divides the area of the triangle into two equal parts. So if suppose the area of the triangle is A, then the area of this triangle here must be 1/2 of A, and the area of the triangle of the trapezoid here is equal also to 1/2 of A. Now we can use the properties of similar triangles because from here it can be seen that this bigger triangle and this smaller triangle are similar. Okay, so what is the property or the equation that is useful to this problem? So we have the equation regarding the areas of similar triangles. So let's say that the ratio of the area of two triangles is equal to the square of the corresponding sides of the similar triangles. So suppose we get the triangle 1 as the smaller triangle, and we consider the triangle 2 as the bigger triangle. So let's substitute. So the area of the smaller triangle, that is A1, is equal to 1/2 of A, and the area of the bigger triangle, that is A2, is equal to A. And the sides that we are pertaining here is x and 188. Uh, so let's substitute x over 188 squared, so that so this becomes x is equal to x over 188 squared, so that our x is equal to the square root of 1/2 times 188. So x is equal to, so let's go back to mode 1, square root of 0.5 times 188, 132.94. So x is equal to 132.94 meters. So this is the value that we are looking for. So that's how we utilize the properties of similar triangles in solving the problem efficiently and with using the shortest solution possible. So, okay, thank you. And that is our module for the solid mensuration triangles. Thank you.